All right, good morning, class. Today we're going to go over exponential decay. This is the other half of the lesson. We did exponential growth the other day. So these are exponential decay notes. Now, exponential decay occurs when a quantity decreases by the same rate over the time. So this is very similar to our exponential growth equation, but the big difference is instead of adding the rate, we're going to subtract it. So A, it is still your initial or your original value. R is still the rate. And once again, it must be given in decimal form. And T is still the time. How many days, weeks, years, months did it take? We're going to do the same thing we did yesterday, but make sure this time, since we're going to be decreasing, we've got to subtract the rate. Let's work the first example. So it says the population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Write an exponential decay function to model the situation, then find the population in 2008. So first, we're going to take our equation and plug in what we know. Y equals A times 1 minus R raised to the T. So yesterday, we worked with it saying plus the rate. Today, we're going to subtract the rate. So we got Y equals... And we started out, and don't mix up the year with the people. We had 1,300 people, so that is our original value, 1,300. Times 1 minus the rate. It says 1% per year. So take 1% and change it into a decimal. You go 1, 2 backwards. There's your new decimal place. Put in a 0. So it's going to be 0.01. And then raise it to the time. So this is what we can put in our calculator to graph it and see what's going on. Now the last thing, we want to find the population in 2008. But the time is not 2008. We started in 2000, so what we have to do is subtract. And when we subtract 2000, there's 8 years that go by. So that is what we're plugging in for the T here. So we got Y equals 1,300 times 1 minus 0.01 to the 8th. And from here, just like yesterday, you can graph it and then you can find your answer, or you can just plug it in. Now when you plug it in, we can combine those middle terms in the parentheses, so we get Y equals 1,300 times 1 minus 0.1, which would be 0.99, and raise that to the 8th. So on yesterday's notes, anytime we combined them, we got a value bigger than 1. So like in our first example, we added 1 plus the rate and we got something bigger than 1. Today, when you do 1 minus the rate, you're getting a number smaller than 1. So now we're just going to plug it in and see what we get. So I've got 1,300 times 0.99 raised to the 8th. 1199.568. And since we're talking about people and a population, we're going to round it to the nearest whole. So right here, that 5 makes a 9 round up to a 10, and everything will go up 1, so this is going to be 1,200 people in 2008. Now, the other way is when you get the equation before, and you're going to leave the time as your x, you can go into your Y equals, and you can type in this equation exactly. So 1,300 times 1 minus 0.01 and then raise it to the x. So this is what our graph will look like. And once again, since it started out at 1,300, it's really hard to see. But we can go into our table and we can find the point. We need to find 8. So at 8, and we still get 1199.568, which rounds up to 1,200. So you get the same number either way. You pick the method that's best for you. I'm going to stop the video here. We're going to continue on the next video.